Good evening, dear children. In previous video, we discussed some questions, last exercise. Up to 8 questions we were solved in previous video. I think this is the last video of the topic, circles. So, see the question number 9. The question is, in figure xy and x dash y dash are two parallel tangents to this circle at P and Q. Another tangent AB to the circle at the point C. This is given in the figure. The question is, we have to prove angle AOB 90 degree. Angle AOB, this angle is equals to 90 degree. So this we have to prove. So to prove this, we need some construction, that is construction. We join O and C. Join OC. Our intention is that at last we prove angle AOB. This angle is 90 degree. So we joined OC. Two triangles are formed. Compare these two triangles. In triangle APO and triangle ACO. Consider these two triangles. Compare these two triangles. In these two triangles, the side OP of this triangle is equal to the side OC of this triangle. OP equals to OC. Just tell me why these two are equal. The side OP of this triangle is equal to the side OC of this triangle because they are the radii of same circle. Radii of same circle are always equal. Then observe here, the side OA of this triangle is also equal to the side OA of this triangle because it is common to both the triangles. So OA equals to OA because common side. And the side AP of this triangle is equal to the side AC of this triangle. Just tell me reason why these two are equal. Yes, theorem number 2. A is an external point. AP and APAC are tangents to that circle. Tangents drawn from an external point to a circle are equal in length. So by the theorem number 2, these two are equal. That is AP equals to AC. This is because of theorem number 2. Okay. Now all the three sides of this triangle are correspondingly equal to the three sides of this triangle. Now I would like to say these two triangles are congruent. That is, triangle APO is congruent to triangle ACO because they obey SSS congruency rule. Yes, SSS congruency postulate. What it states? The three sides of one triangle are equal to corresponding the three sides of other triangle. Then the two triangles are congruent. Yes, this is SSS congruency postulate. So here also these two triangles are congruent. Understood? Then if triangles are congruent, means their corresponding parts, that is corresponding element, angles and corresponding sides are equal. So these two are congruent. Just flip this triangle over this triangle, they exactly coincide. Then this angle is equal to this angle. This angle is equal to this angle. Just tell me, this angle is equal to angle AOP. This angle is equal to this triangle. This angle corresponds to angle AOC. Clear? So now, hence the two triangles are congruent. These two are corresponding angles and they are equal. So now angle AOP is equal to angle AOC. This angle AOC, region CP. Corresponding parts of congruent triangles are equal. So now say this result is 1. And similarly, observe here dear children, similarly we can prove these two triangles. Observe these two triangles. They are also congruent triangles. The side OQ is equal to the side OC, and OB is equal to OB common side, and QB is equal to BC. This is an external point. By theorem number 2, these are the two tangents to this circle. By external point to the circle, the tangents are equal in length. So the three sides of this triangle are equal to the three sides of this triangle. So by SSS, these two triangles are also congruent. That is, triangle OCB is congruent to triangle OQB. Reason, they follow SSS congruency postulate. That is why they are congruent. Once triangles are congruent, their corresponding parts are equal. Corresponding parts of congruent triangles means corresponding sides and corresponding angles. So these two triangles are congruent. Flip this triangle over this triangle, they exactly coincide because they are congruent. This angle is equal to this angle, this angle is equal to this angle, and this angle is equal to this angle. That is, see here I mark, that is angle COB is equal to angle BOC. This is because of CP. Say this result is 2. Okay. So we want to prove angle AOB is equals to 90 degree. AOB is equals to 90 degree means, where is that angle? Just tell me. Here it is, AOB. We have to prove this angle is 90 degree. Now, so with respect to AB, with respect to circle, this PQ is diameter. Yes. So don't consider that line with respect to circle. Without circle, that PQ is a line. Since in figure this PQ is a line. What it is? Line. And we know that there are many rays standing on a line. So 1, 2, 3, 4. 4 angles are formed. Sum of these all angles on a line, that is equals to 180 degree. So we follow the same concept. Here PQ is a line. So this angle plus this angle plus this angle plus this angle, the sum of these 4 angles is equals to 180 degree. That is angle POA plus angle AOC plus angle COB plus angle BOQ. What is the sum of these all angles? This is equals to 180 degree. Now observe here. In result 1 we showed that angle AOP is equal to angle AOC. So means this angle is equal to this angle, because these two triangles are congruent. We showed that result here. through that these are CPCT, these two angles are equal. So instead of this angle POA, instead of this angle, now I write angle AOC because both the angles are equal, that we shown in result number 1. So instead of this I will write angle AOC plus, write angle AOC as it is, plus angle BOC, write this angle as it is, angle BOC plus, instead of this angle BOQ, instead of this I would like to write as angle BOC because we proved that in result number 2 angle BCOB is equal to angle BOC. Because these two triangles are congruent, then these are corresponding angles and hence they are equal. That is, this I will write angle BOC equals 180 degree. So then find the sum. One angle AOC plus one angle AOC. What is the sum of these two angles? That is 2 times angle AOC plus angle BOC plus another angle BOC. This sum is also 2 times angle BOC is equal to 180 degree. So then what is the common in LHS part? 2 is common. Take it outside. What remains inside? Angle AOC plus angle BOC. This 2 is outside, common factor, is equal to 180 degree. Then here 2 is multiplied. Shift that 2 to right side. Angle AOC plus angle BOC. Shift this 2 to other side. That becomes division. From the figure, observe very carefully. Angle AOC plus angle BOC, that is angle AOC means this angle, not this angle, this angle. Angle AOC means this angle plus angle BOC, this angle. This angle plus this angle, what is the sum of these two angles? That is nothing but angle AOB. So the sum of these two angles is angle AOB. 180 divided by 2 is 2 1 ja 290. So 90 degree. Hence we proved that is angle AOB. So means this angle is how much? 90 degree. Clear? So dear students, pause the video, write the proof, and we will meet shortly. And then we solve that 10th question. Write it down. Okay, dear children, see the next question. Prove that the angle between the two tangents drawn from an external point to a circle, that angle is supplementary to the angle between the radii. So first, according to the question, we draw the diagram. That is what we are given. We are given a circle. Yes, with center O. Take a point P, which is external point. PB and external point. There are two tangents from external point to this circle. Say these are the two tangents to this circle from external point P. This touches at A, this touches at B. We prove the angle between the two tangents drawn from an external point to a circle. So means where is that angle between the two tangents? This is the angle between the two tangents. These two tangents are drawn from this external point now. Okay, this angle is supplementary to the angle between the radii. So now join OB and AO. So angle between the radii is this one. This is the angle between the radii. These two radii are drawn from the point of contact. For such angle, this angle is supplementary. This angle is angle between tangents. This angle is supplementary to the angle between the radii. So write this symbolically. What we are going to prove? We are going to prove angle APO, angle between the tangents, APO, angle APO plus angle AOB, AOB is equal to 180 degree. This angle is supplementary to the angle between the radii. Means what are supplementary angles? If the sum of any two angles is 180 degree, then the two angles are called supplementary angles. We prove here the two tangents drawn from an external point. So this is the angle between the two tangents to this circle drawn from an external point. This angle is supplementary to the angle between the radii, which are drawn from points of contacts. So this angle plus this angle is equal to supplementary, means their sum is equal to 180 degree. This we are going to prove. So then to prove this, observe the proof. Since observe the figure, APBO is a quadrilateral. Observe this figure. This figure is closed by 4 straight line segments. So the geometrical figure which is closed by 4 line segments is called quadrilateral. So here also this APBO forms quadrilateral. Since APBO is a quadrilateral, this is quadrilateral. Yes. Then what is the angle sum property of a quadrilateral? What is the angle sum property of a quadrilateral? Yes, this is quadrilateral. The sum of 4 interior angles of quadrilateral is 360 degree. This we learned in your previous standard, that is in 9th class. So the sum of these 4 interior angles is 90 degree. That is angle A, this angle plus this angle plus angle B plus angle O is equal to 360 degree. This is because of angle sum property, angle sum property of quadrilateral. The sum of 4 interior angles of a quadrilateral is 360 degree. Now, just tell me dear children, what is the measure of this angle? That is exactly equals to 90 degree, because in theorem number 1 we studied that this is the tangent to this circle, this is the radius. Radius is drawn through the point of contact. So tangent is perpendicular to the radius through the point of contact. So that we learnt, yes, in our previous videos. So the measure of this angle is 90 degree. So right here 90 degree. This is the angle between tangents that we don't know. So write as it is plus here what is the measure of this angle? This is also 90 degree, because this is tangent, this is radius through the point of contact. So tangent is perpendicular to the radius through the point of contact. So perpendicular means that makes angle 90 degree. So the angle B is also 90 degree plus write the measure of angle O as it is equal to 360. So 90 plus 90, 180 degree plus angle P plus angle O equals 360 degree. Then shift this 180 degree to other side. Angle P plus angle O equals to 360 minus 180. This becomes minus 180 degree. Then angle P means that is the angle between tangents, that is angle APB, this angle, plus angle O means that is angle between radii, that is angle AOB equals to 360 minus 180 is 180 degree. Hence we proved the relationship. So what it is, angle between the tangents is supplementary to the angle between the radii. Those radii should drawn from the points of contact. Clear? This is the proof of that 10th question. So dear children, again pause the video and write the proof. Okay. Okay, dear children, while solving this 10th question, I made one mistake. That is, I wrote here angle APO. Yes, that is not O. That is angle APB. APB. Yes, sorry for that. Now, see the next question. Prove that parallelogram circumscribing a circle is a rhombus. Okay, so that is there is a parallelogram. Now say this is A, B, C, D is a parallelogram circumscribing this parallelogram circumscribing a circle prove that parallelogram circumscribing a circle is a rhombus. Actually, this is not parallelogram. Actually, it is rhombus. We have to prove that. So ABCD is a parallelogram. According to them, ABCD is a parallelogram circumscribing a circle. Yes, we prove that is not parallelogram. That is rhombus. Clear? So what is given? Given ABCD is a parallelogram. Yes or no? ABCD is a parallelogram according to the given data. To prove, we prove that is not parallelogram, that is rhombus. We prove ABCD is a rhombus. We prove ABCD is a rhombus. Clear? So now see, prove. Dear children, given that ABCD is a parallelogram, given ABCD is a parallelogram, let's apply the property of parallelogram. In a parallelogram, opposite sides are equal. AB equal to CD and AD equal to BC. These are the properties of parallelogram. In parallelogram, opposite sides are equal. So take that result. ABCD is a parallelogram. So AB equal to CD and AD equal to BC. Say this result is 1. Okay. So now we prove this is not parallelogram. This is rhombus. And the parallelogram becomes rhombus. In parallelogram, only opposite sides are equal. In rhombus, all sides are equal. So then think, when the parallelogram becomes rhombus, when all sides of the parallelogram are equal, then that parallelogram is rhombus. Yes or no? That we studied in our previous standard. Yes, in parallelogram, only opposite sides are equal, but in rhombus, all sides are equal. So when parallelogram becomes rhombus, when all the sides of parallelogram are equal, then that parallelogram is now rhombus. So first we prove all these sides are equal, then automatically it is rhombus. Okay. So ABCD is a parallelogram. This is from given data. Through this we made one result. Now circle touches the sides of parallelogram at P, Q, R and S. Say this is P, this is Q, this is R, this is S. Okay, dear children? Then, now, by theorem number 2, length of the tangents drawn from an external point to the circle, these two tangents are equal in their lengths. This is theorem number 2. So apply theorem number 2. Here A is an external point, AP and AS are tangents, so they are equal in length. This we studied in theorem number 2. So apply theorem number 2. AP is equal to AS. Say this is 2. BP is equal to BQ. BP is equal to BQ. Say this result is 3. Similarly, CR equal to CQ. CR equal to CQ. Result number 4. DR is equal to DS. DR is equal to DS. This is result number 5. Okay, dear children. So it takes some more space. So just a minute. I will drop this portion. Okay. Until now, think about this. What I wrote and try to understand this. Okay. Just a minute. Okay, dear children, add these 4 results, that is adding and 2, result number 2, 3, 4 and 5. In our previous video we learned how to add such equations, add their LHS and RHS, that is AP plus BP plus CR plus DR plus CR plus BR is equal to AS plus BQ, AS plus BQ plus CQ plus DS, CQ plus BS. Now, from the figure, observe carefully. AP plus BP, AP plus BP is totally AB. CR plus DR, CR plus BR is totally CD. AS plus DS, AS plus DS is totally AD. BQ plus CQ, BQ plus CQ is totally BC. Yes or no? Now see what happens. I will write AB as this, but I will write this CD as AB again. Why? Think about it. ABCD is a parallelogram. Yes or no? In parallelogram, opposite sides are equal. So I made that result AB is equal to CD. So instead of CD, I would like to write as AB because these two sides are equal. In parallelogram, opposite sides are equal. Or I made that result. Use that. AB equals CD. So instead of CD, I wrote AB. Then AD is there no? Instead of that AD, I am going to write BC. BC. AD is equal to BC because ABCD is a parallelogram. Okay? AD equal to BC. Then write this BC as this. AB plus AB, 1AB plus 1AB, 2AB. BC plus BC, 1BC plus 1BC, 2BC. 2 is multiplied. Shift this 2 to right side. AB equal to 2BC by 2. Yes or no? Then 2 gets cancelled. AB equal to BC. We obtained one more result, that is AB equal to BC. Say this result is 6. Yes or no? Now observe here, dear children, from result number 1 and result number 6. Observe very carefully. What is your conclusion? From result number 1 and from result number 6, what is your conclusion? Yes, think of it. Very good. So from 1 and 6, all the sides of this parallelogram are equal. Yes, see how. What do we obtain here? AB equal to BC. Yes or no? Then that AB is also equal to what? CD. So this AB is also equals to CD. Yes. Again this BC is there, no? That BC is equals to AD. That BC is equals to AD. So means from 1 and 6, all sides are equal. These all sides are equal. Yes. All the sides of the parallelogram are equal, then that parallelogram is rhombus, hence proved. Yes or no? That is, which implies all the sides of parallelogram are equal. When all the sides of parallelogram are equal, then that parallelogram is rhombus. Hence ABCD is a rhombus. Clear? This is the proof of question number 11. Okay, dear children, this is the last video of the topic circles. Clear? So question number 12th one and 13th one, try to solve, and I will send you solutions in PDF form. You have to write all the solutions and all the exercise questions, fill in the blanks, what are those, no? That all you have to write in parents. So now this completes your topic circles. So for exam point of view, you just prepare definitions of secant, tangent, non-intersecting line, point of contact, and first exercise fill in the blanks are there, no? Prepare those also, and there are some numerical sums. Find OD, find what is the radius of the circle. Some numerical questions are there, no? You have to prepare those also. And for 3 mark question, you should prepare the 2 theorems, theorem number 1 and theorem number 2. So this is about exam point of view. Clear? So then in the next video we are going to discuss the new topic. Okay? This completes your circle topic. For exam point of view, we have to prepare definitions, fill in the blanks, numerical sums, and 2 theorems, theorem number 1 and theorem number 2. Yes, prepare this much and you can get easily 4 marks on this topic. One theorem is for 3 marks, 1 mark. It may be in MCQ, fill in the blanks, true or false, some logic questions related to circles. Okay, write these all notes in your pair notes. One day I will call you to come to school and I will check your pair notes and I will verify. Understood? Okay, dear children, in the next video we will discuss the another topic. Okay, bye. Right.